Okay, so now let's take a look at function magnitudes and their rates of change. So function magnitudes and their rates of change. So now, okay. All right. I got like totally sidetracked now. Okay, so looking at this, it says let f of x and g of x be positive for sufficiently large values of x. F grows faster than g, and g grows faster than f as x approaches infinity. Okay, so now if the bottom is growing faster, it goes to 0. If the top grows faster, it goes to infinity. F and g grow in the same rate. Okay, as x goes to infinity, then we take the limit. It cannot equal 0. Right here for this. So it would equal 1, but not 0. All right, so let's take a look for this one right here. So I'm going to do the first example. I'm going to do it on paper. So it says f of x, so it's going to end up becoming the limit as x approaches infinity. We have 5x cubed minus x squared plus 3x minus 6 all over 5x cubed. Now, we did this already, and I showed you guys the trick. Okay, I already showed you guys the trick. The behavior of it, I have the same degree. So what would this be using the trick that I showed you? So same degree. It'd be 5 over 5, right?
Yeah.
5 over 5, which gives me 1. But now I'm going to show you guys a little bit more of how to do this, because that's just using the trick. So now I'm going to actually do a couple other things. So is this a monomial? Say yes.
Yes.
Monomial means one term. One term right here. So I have a monomial. So I have a quadrinomial divided by a monomial. So that could divide out equally. So I'm going to take each term and put it over this. So that's going to become 5x cubed over 5x cubed minus x squared over 5x cubed plus 3x over 5x cubed minus 6 over 5x cubed. Alright, so now, as I take the limit as x approaches infinity, let's start with this one right here. Which one has the greatest degree? The bottom. So this goes to? That goes to 0. Same thing goes to this. So this becomes 0. This becomes 0. This becomes 0. And so this one right here, I have the same right here. So now it's going to be going at the same rate. So that means that this is going to be 5 over 5, which just gives me 1. So this is going to give me my limit is going to equal just 1. 5 over 5, which is 1. All right, so now there's another one that I'm going to explain. You guys that in that other calculus class are not going to know what I'm doing. Okay?
What other calculus class?
Hmm? You.
Why don't you add us?
Okay, so you guys are really not. Just go with it, okay? So you'll learn more about this later. Okay? It's L Hospital's rule.
Right?
Hospital? Hospital? Okay, then show me how
Do we look for it?
Yeah. Are we missing out?
It's like a jump. Like, what are we missing out on?
Okay, it's
Next semester.
no, they'll do it in
Yeah.
by the end of this semester.
I feel like we learned it last
Why
semester.
can't we learn it now? Why can't we learn it now?
Okay.
You are.
Hey, listen up. I'm trying to teach it to you right now. So we're taking the limit as x approaches infinity of x to the 5th over e to the x. Now, for L'Hopital's rule, it's L hospital, Hospital.
Did
Okay.
you say it local?
Yeah, it's L'Hopital.
Like L hospital.
Yes, okay, but still, it's that.
It's little hospital.
I know, French people. Anyway, so this rule has to do with the derivative. So you actually have to know how to take a derivative, and I'm going to show you guys how to do this. So you guys are going to get mad at that other person
The guy upstairs.
because
Oh yeah.
this is the voodoo way. This is the way that is really quick and really easy, and you're going to have to find derivatives the very long and algebraic way. But
Ooh.
okay, so for this to work, I have to look to see, okay, so as I plug this in, if I plug this in, do I get infinity over infinity? Say yes.
Yes.
Yes, it's going to get infinity over infinity. I just don't know which is going to be. So L'Hopital's rule works at a couple different places. It's called the indeterminate. So when you plug it in, the indeterminate would be infinity over infinity, 0 over 0, negative infinity over negative infinity. Okay? So those are when you can do this. So we're going to have infinity over infinity. So now I'm going to show you how to take a derivative. Okay? Not using limit process, just doing the voodoo way. So you take this number. The exponent is what? Say 5. So that number goes out front, and I subtract 1 from the exponent. So let me see. So if I call this one F and call this one G, F prime is going to give me 5 x to the 4th over G prime. Now the derivative of e to the x is only e to the x. That is an identity. It's one of those things that you're going to come up later. So when taking the derivative of this, derivative of e to the x is just e to the x. The integration of e to the x is e to the x plus c, right? Okay. Yeah, anyway. All right, so you're going to have e to the x anyway. So now the first derivative of e to the x is just e to the x. Now, can I plug in infinity now? Say no.
No.
Is that going to give me infinity over infinity again? Say yes.
Yes, yes.
It's going to give me infinity over infinity, isn't it? So since it's infinity over infinity, that means I could do it again. So f double prime over g double prime. So now, right here, so that 4 is going to go out here, right? But there's a 5 already there. So I multiply, so that's going to give me, say it, 20 x to the, how many? 3, right? Okay. Over e to the x. Okay. Is that take care of it yet? Say no.
No.
It doesn't take care of it, right? I still get infinity over infinity.
So 20 times 3.
So f triple prime over g triple prime is going to be
60 x squared.
over,
E to the x
very good.
squared.
Okay. Now, so is that infinity over infinity?
Yes.
Okay, let's do it again. So f 4 g 4. Usually they don't use like 4 tick marks. It goes to the number. All right. So f4 g4. So what's that going to give me?
120
120x over.
e to the x.
Okay. So now is that infinity over infinity? So f fifth g fifth. So take the derivative.
It's 1.
Huh? 120, but now what is it? X to the 0. You have to subtract, right? X to the 0 is just going to be 1. So that means the x go away. The variables go away here. So now it's just going to be 120 over e to the x. Now, if I plug in infinity here on top, is that going to give me infinity on top? No. What is that going to give me? 120 over e to the infinity. So which one is going to race faster? The bottom. The bottom is going to race faster. So if the bottom races faster, like goes to infinity faster right here, that means what? What is the limit for this? 0. That goes to 0. The bottom is bigger, it goes faster, that's going to go to 0. Does that make sense? It's,
Yeah.
I know I showed you guys the voodoo magic on here, and most of you guys haven't had it yet. Not most, maybe half. We'll see. Anyway, so that's L'Hopital's rule, and when you start doing derivatives later on, okay, you have to remember this. Okay, you have to remember this. You can't use this unless you stated infinity on infinity, 0 over 0, negative infinity over negative infinity. Okay? So you have to be able to state it first or write out the words that it is indeterminate. All right, so let's take a look at the next one. The next one I have for you guys, we're taking the limit as x approaches infinity, and I have log of, so basic log over ln x. Oh, there we go. Okay. Now, what's the base of log? 10, right? The base of log is 10, isn't it? That's very important. The base of log is 10. So if it doesn't have a number there, it means that it's going to be 10. So now, because I have ln's, which is a different base, what is the base of ln? E. It is, yes. The base of ln is an e. So when I actually e and ln, don't they cancel? All right, ln and e, those cancel, right? Okay, so now because of that, now I'm going to do a change of base. So this is something that should have been algebra sometime. Quite possibly it wasn't. All right, so now I'm going to rewrite this first before I do this so I don't lose anyone. So isn't this log of x to the 1/3 over ln x? Yes? Okay, good. So now, this, when I do a change of base, can't this come out front? Okay, the 1/3 could come out front, right? So this is going to be the same as saying log of x over 3 ln of x. Because the 1/3 went out front. Yes? The 1/3, my exponent here could go out front in front of these. So, since the exponent's going here, so now I'm going to do the change of base on the top. So I'm going to do a change of base, and I'm going to change it to ln. So by doing that, it's going to turn into ln of x. So it's the ln of x, which is this right here, over the ln, what is the base of log? 10. So it's going to be ln of 10 all over 3 ln of x. Does that make sense? Did I lose anyone with this right here? Yes? Okay, so here's the rule. here's the rule. Whenever I'm doing a change of base, so it's going to be, I don't want to see through that. All right, so it's going to be log base A of B. Okay, my base is going to be the A. Now, I'm going to do a change of base because not all the time, so when I'm ever doing the math to go along with this, my A, I'm going to get like a log base 5 or log base 2, something weird that I really can't work with here. So I need to change it to use ln because ln is a whole lot simpler to work with here. Okay, I'm telling you it is. I know you guys are like, oh crap, he's saying ln is simple. I don't even know what ln stands for. Okay? Now, if we ln, look, if we ln and e, we get what? We get just 1, right? Or if I have e to the ln, I also get 1. Okay, they're inverses of each other, so I can actually get that. So using this properties here, these properties, I can make this math a whole lot simpler. Now, a change of base is what we're doing here. So the base is A, but now on the bottom, my base is E, isn't it? So technically, log base E x. Is that what that's what that says right there. Right here. So the ln is actually a base E. And this is just a different way of writing it. Okay, but you don't ever see it like this because you write it as natural log. You write this as natural log because my base is E. Alright, so now I'm going to fix this. So now this turns into, so this goes on top. This goes on top. So it's ln of B divided by my base ln. So it's a change of base. So it's changing it to the ln of A. So it works all the time like this. So this is what a change of base does. Okay, it changes it to be 2 different fractions. And now, because I can have it like this, there's a reason why I want to do it like this, because this works a whole lot better. Now, I know if I'm dividing, it's going to help me out later on. If I know that there's division, you know what, I know that this cannot equal 0, and all this other stuff that goes along with it. Okay? So, algebraically, I need to turn it to this. Now, I have a fraction over fraction. Actually, before I go on, is everyone okay with just this part here? Okay, this is something you guys should know. And if you don't know it, it's fine. You'll learn it. You will practice it. You'll be doing it a lot. So in between now and the AP exam, you're going to have a bunch of these things where you have to change a base and actually go back through this. Okay? So now, we have a fraction in a fraction. I don't like fractions over fractions. Okay? So you can't have a fraction over fraction, so you have to multiply by the reciprocal. So now this is over 1 right here. That's over 1. So I'm going to do all this, so I'm going to change this. So it's going to be, the top stays the same, ln x over ln 10 times the reciprocal. Since this is over 1, because I made a fraction over fraction, and all whole numbers could be rewritten as over 1. So now, because of that, I'm going to do the reciprocal of this. When I reciprocal this, I'm going to flip this over. So I'm now, instead of dividing, I'm multiplying by the reciprocal. So the reciprocal is going to be 1 over 3 ln of x. Now, since there's the multiplication happening here, what could I do now? I could do what? Cancel out, right? Since I have an ln x on top and an ln x on bottom, I could cancel this out. Bam. Bam. So now, because I'm able to cancel those out, I'm now left with 1 over 3 ln of 10. Now, did I have to take a limit here? No, I didn't take a limit. All I did was I was able to remove this. I was able to remove the fact that I have a variable in here. So now the limit of this is going to be here. So that's what I'm going to end up with this on here. Does this make sense? Did I confuse anyone? My answer is this. Should I box it? Or for those other people that have that one teacher, put ANS? You guys probably shouldn't have had that one teacher. But yeah, anyway. Questions? You guys just staring at me awkwardly? Are we okay with this or no? Yeah? Okay. Alright, so let's...
Practice problem.
Are we up to the practice problems now?
Yeah.
Okay, so practice problems. So, okay, I'm going to give you guys a couple minutes before I get to continuities. Okay, do it.